Hello and welcome to Preprints in Motion. Join us as we sit down with early career researchers and discuss their latest preprint and find out about their journey through the muddy marshes of academia. But we don't stop there. Every month we'll be bringing you special episodes with open science leaders where we discuss how to fix academia. Easy, right? So hit that subscribe button, leave a rating, or find us on Twitter at MotionPod. But for now, let's get into the show. This week we're joined by Nori Park and Jennifer Byrne. Join us as we discover why you shouldn't be putting quite so much faith in those nucleotide sequences you keep coming across. So thank you so much for joining me today. It's early for us here. Well, it's not early, it's 9 a.m. It's not that early. It's the earliest one we've recorded though, which is why John's not here. John is currently training a new technician up in his lab, which I'm sure he'll be thrilled about having John as a boss. We should cut that out actually. John does all the editing, so he's going to hear it.
Sure, he's a lovely person.
I'm sure he's lovely to work for. He's very nice. So maybe we can leave it in now. I've said something nice about him. So you've done a really, really cool preprint that I'm very excited to talk about. And we'll get into why I'm excited about it in a bit. But I think to start, it would be really good if we could just introduce yourselves, because we've got two guests again. Would one of you like to jump in and give us a little introduction about who you are and your background?
Jenny, you want to go first?
Well, Nori, I think you're the main person today, but I will go. I'll go first, just to sort of lead you into it. So my name's Jennifer Byrne. I'm a research scientist from Sydney. I'm a cancer researcher by background, and I've been studying, I guess, problems in the cancer research and genetics research literature since about 2016, and this is what this work's about.
So my name is Nori. I'm Jennifer's research associate. I did my honours at the University of Technology in parasitology, actually. Spent a bit of time working in a private pathology lab. And then about last year, I joined Jennifer on her project looking into, I suppose, problematic papers originating from certain companies.
That's very, very diplomatically put, that was.
Yeah.
So you did a bit of forensic science, right? As an undergraduate?
Yes,
so that,
just a little bit.
That must lend itself very well to this kind of investigation.
It's kind of what Jenny says a lot. I personally don't see that, to be honest. I suppose the way of thinking might be a little bit different. In forensics, at least the ETS, one of the things that they emphasize is you really can't be sure if someone has actually done a crime until... you really can't ever be sure. It's all about the statistics and how unlikely things are, which I suppose does help out in this work. Kind of instead of just pointing fingers and saying, oh, we think this is bad enough, I feel like it puts me a bit on edge to try and keep searching until it gets to a point where I can't really dispute certain things. Otherwise, I actually don't think forensics helps as much as anyone would think.
The reason I like this work so much is when I was a master's student, years ago now. I was trying to work out how many years. That many years, I can't work out how many years ago it was. In the lab I was in, I was once told, we were doing a lot of qPCR screening stuff, and I was told to go to one of the lab's recent papers to get the sequences we needed to reorder the primers we were already using. And I can't remember why I did it, but just out of interest, I guess, I blasted all these primer sequences, and quite a few of them were wrong. And they were not the targets they were supposed to be. And these were the ones, this is the paper the lab went to every time they wanted to reorder their own primers. And so I learned that lesson very early on, that you cannot trust anything out there. And so ever since, every time I come across a primer that I need to use, I always check it, every single one, whether it's from the lab I've just joined or whether it's in a paper from someone I have no idea who they are. And it is, you won't be surprised, but I was surprised how often those sequences were not right. In fact, some of them not even close to being what they should be.
That's kind of it, I think. Some people have asked us, are these just like small errors or internal errors in the primers, but really, the errors that we're pointing out, they're not even close. As you say, they're just completely unrelated sequences, which is, concerning.
So you've gone through a lot of papers and looked for these genetic sequences that papers have. So papers have genetic sequences for a lot of different reasons. qPCR would be one of those. Primer pairs for PCR. And these are really important because we need these to then replicate the results, or, saves us time in designing them ourselves, which can take quite a while, which I guess is why some of them are probably wrong. So could you give a little bit of background as to where the idea for this came from?
Yeah, sure. I guess this work is continuing on from work that we did some years ago where We originally found incorrect nucleotide sequences in gene knockdown papers. And so, we published a paper in early 2017 that described a fairly small set of papers that had incorrect sequences, and often the same sequence repeated across multiple papers, which I found, pretty strange at the time. And in science, sort of one thing leads to another. So we knew about this kind of paper. And so fairly quickly, we realized that there were probably other variations on these knockdown papers out there. So we wanted to look at some of these variations to see whether there were different kinds of papers that have wrong sequences. And we also, because of course, with these kind of cohort studies, we're basing our analyses on features of papers that we know about. We wanted to also screen some journals and really do a kind of an unbiased look to see whether we could find papers in particular journals and what the frequency of those papers were and what kinds of papers they were. Could we discover new things by actually taking a look at a journal over time? And so we did that with 2 journals in this study.
And so you ultimately found over 700 papers that you described as problematic. And that was over 1,500 wrongly identified sequences, which is that's a big number for what is supposed to be quite a simple... Because a sequence, I've never understood why these are wrong, because when I'm designing my primers, I take the sequence I've blasted and I paste that into my document, which has got all my primers in it. And then whenever I need to put that into a paper, I copy and paste that into the paper. And so for me, I don't understand where that could possibly go wrong and the sequence could be changed.
Yeah.
Yes. I know that Nori has found some papers where, he can probably give more detail, where he felt that he could see how the error could have happened, in some cases.
I actually don't know what we can and can't go into, because sometimes it might be a little bit too crazy. But at least majority of our papers were from China and affiliated with hospitals, which in itself is a bit of a separate issue. But then that means the minority of our papers were from several other countries unrelated around the world. And for those papers, sometimes you could see where the issue was. Every time this comes up, I bring up the case where there's a paper from South Korea on a data set where they had studied 3 genes and had provided the primers for those 3 genes, but they had just simply pasted them in the wrong order. I don't really know how common that is, because I can't really say I've done as much research as everyone else has here. I think in that sense, you can kind of see, okay, it might have just been copy-paste error in the moment of signing. There was a case where sometimes they paste the nucleotide, but I assume they must have typed it in manually sign, because 2 sequences are mixed up with signing. But unfortunately, most of the sequences that we came across in our data set, like John said, it's not really something you can explain that easily. Yeah, some of it does seem a bit dubious and a bit, I don't know. Do you want to jump in, Jenny?
Yeah, I guess some of the more difficult things are sequences that, don't seem to correspond to really anything, that we can't identify as, for example, we've only studied human research, so we have sequences that don't seem to have any target in the human genome. And it's hard to understand how those kinds of sequences, particularly as PCR primers, end up in papers. We have also quite a lot of cases where targeting reagents are targeting genes that weren't described in the paper. That's also hard. I think when you can see how people might have swapped a couple of primers over when they're studying many genes, but when you're starting to see things targeting things that were just not even mentioned, I think that's, we find that it's just hard to understand as somebody who's done these kinds of experiments. As you say, you know how you usually work. You're very aware that you can get sequences wrong. They're just completely anonymous strings of letters, and so you actually have to work quite hard to make sure you don't make these mistakes. And when you see these very, very unusual mistakes and multiple mistakes per paper, that's also something that I think we find, concerning. Yeah.
Yeah, I think that's when I've come across it, because I've been so far in my career working across multiple different species. Every step I seem to change species and cell type. And so I've kind of blasted genes across lots of different species, and often you'll find things in that are supposed to be targeting fruit fly genes, for example, actually target human genes. And there's no fruit fly gene at all for that sequence that sequence is supposed to be targeting. Or you'll have papers where, if I'm familiar, particularly examples where I'm familiar with the lab, the sequence that's targeted is something that lab will there's no reason they've ever looked at it. So that really is a completely wrong sequence, and it's very difficult to understand how that has gotten in there by accident. Which I'm sure it was. I'm sure most of these are accidents. I mean, where would you say responsibility lies for that? Is that something that the authors should be catching, or do you think this is something an editor should be checking? Because it's not a difficult thing. It takes like 5 minutes to check a few primers.
No, it's not hard. Primarily, I guess authors are responsible for what goes in their papers. I think people have sort of said to us, do you think peer reviewers should be checking this kind of thing? And most people will say, well, no, peer reviewers won't do it. They don't have the time and they don't have the energy, and peer reviewers are meant to be looking at the general contribution of the manuscript to the area of research. They're not meant to be digging in and doing this kind of forensic analysis.
Yeah, I mean, that catches very nicely onto what I like to quite often complain about when people bring up peer review, is that peer review, it's often brought up as this validation of a paper, but if they're not checking this kind of thing, it's not a validation of the paper. It's just, we kind of like this science, or we don't, and so we're going to reject it. Okay, so you had sort of two approaches to this. You've got this seek and blast N method, and then you did a manual investigation, which I assume was a lot of fun. Could you explain how that seek and blast method works?
Yeah.
I've been calling Nori the seek and blast whisperer, so I think he should be answering this.
I did not enjoy that. So a colleague of Jenny's a while back called Sil Larbe, he's absolutely fantastic with everything. But he went and a while ago put together I suppose text mining tool, which is what seek and blast N is. And to kind of just summarize it, it's basically has a PDF extractor that looks for nucleotide sequences specifically, as well as the identifiers. So if an article is saying GAPDH is the sequence, it'll extract both GAPDH and the sequence itself and run them on a local version of BLASTN. And it'll basically show a kind of color-coded screen of whether or not this sequence does match to GAPDH or not. The slight issue is that with tools, there's obviously a lot of error that can happen. And when it comes to this kind of work, where a lot of it is sometimes associated with fraudulent behavior, there is a bit of risk in going out to an author and just saying, hey, we think your sequence is wrong, because it might not look great. I think is the best way to put it. So the manual part is just basically taking what Seek and Blast has given us and just manually checking it. So we do that and it's really quite simple, but we just run it in the GNT database for Blast. If nothing pops up there, then we try again in the unrestricted database just to see what the sequence is. Determine if it's the correct identifier or not. Every now and then there'll be sequences, just nothing comes up in unrestricted search. So we'll search that in the human genome browser. I think it's UCSC's BLAT search engine. And once again, if nothing pops up there, then we search it in Google Scholar. And it's kind of only when nothing consistently shows up in any of those databases or search engines that we kind of call sequence as non-targeting. But otherwise, if a sequence does come up and kind of fits our criteria of it having consecutive sequences or consecutive nucleotides binding to the sequence, then we do assign it the identifier that's been given.
Okay, that's very thorough then. That is a really good. I mean, especially as you say, you're kind of the assumption that somebody might be making a sequence up is quite a serious one. So it is good that you're going so in depth on that. How long does that? Do you do that for all of the ones that come up as wrongly identified? Or just a subset?
We usually stick to the ones that do come as wrongly identified. The assumption I've been working is that the local version of Blast on Seek and Blast is a bit of an older version. So if it's, this might be flawed actually, but if it's fine on that, then I'm assuming that on the updated versions, it's probably okay. So yeah, we only kind of look at it as far as it needs to be. If at any point during that stage, identifier does come up, then we'll just assign it to that.
And was there any finding you had that was particularly shocking, like a paper, for example, that had 20 sequences and they were all horribly wrong, or was it just mainly minor, sort of one or two sequences in a paper that were incorrect?
I don't know where to start. Some of them were fine. Like every now and then, like I mentioned before, you come across a paper and you go, okay, I feel a bit bad about calling this one out, but it is wrong, even though I can see where it is. But there were several papers that we came across that just went, I don't understand this. Every now and then it was, they just target the wrong gene and it's like, okay, I don't know what's happening there. But so we identified 1,500 sequences. And I think some of those, a fraction of them, about like 20% of the RT-PCR primers that we found we found they actually targeted animal genes. So this study would be saying we're targeting ZFX in human cancers, and then they try the primer, and we'd find that it doesn't bind to anything in human genome, but it binds to ZFX gene within mice or rats. Occasionally dolphins and turtles came up. I'm not sure how that happened. But yeah, that was probably, for me personally, that's kind of one of the most surprising results.
I've never had that one yet.
Just can't even begin to explain that one, honestly.
I think you had a few papers where, what was the highest number of wrong sequences that we found? I can't remember. I mean, in the journals, I think the median number was 2. So we were talking about at least 2 sequences per paper, but I think some had,
Around 8 was like one of the highest ones, which is, I mean, I suppose it happens. I don't really know if that's the best response, but it happens apparently.
That seems like quite a lot for a paper to be. I mean, that's like you've copied a whole table of primers that aren't the right ones and just gone, yeah, that'll do.
Yeah. There's probably a weak sort of positive correlation between just number of sequences in a paper and wrong ones. And we kind of think of that as a bit of a bleeding obvious result. I mean, that's kind of what's going to happen. But I think one of the things we're starting to look at now is over time, papers tend to evolve from a simpler to a more complex state over time as, what you need to publish in a certain journal increases all the time. So, it's possible that the numbers of primers in papers in general is just increasing, and that can also increase the likelihood that we'll find wrong primers in papers.
Yeah. I mean, you might not have done this, but have you thought about looking at how, so maybe a preprint to its published version and looking at the primers in the preprint and published version of the paper and seeing if they actually are corrected? Where you can identify that they're wrong?
Yeah, it's an interesting idea. I don't know that many of the papers that we study are actually preprinted.
Okay.
I don't think that many of them are. We have suggested that might be a good way of improving integrity in this field, encouraging people to post papers as preprints. Yeah, so that's an interesting idea. Yeah, could look at that.
Yeah, it's something
amongst other things.
Something I've done before, and it's a lot of effort.
Yeah.
But it is interesting. It is interesting to see how little papers generally change.
Okay.
Oh.
Okay.
So we were doing this with COVID preprints because we'd done some other COVID-based work, and we're big in the preprint field, and we wanted to kind of provide evidence because a lot of people who don't like preprints say they're bad quality, and we wanted to challenge that. And yeah, so we found over 80% of preprints that are eventually published, at least that we looked at, just didn't change.
Okay.
And those that did change, generally it was just their findings were a bit better, but the conclusions were still identical.
Okay, that's interesting.
Yeah, so it's an interesting thing to look at, really. So you've already mentioned that you found a lot of papers coming out of China that were particularly problematic. Is there any reason you think that might be the case? Is this just that we're getting a lot of research out of China at the moment, particularly in the past few years, where China's been trying to do that global powerhouse approach, and that's very much translated into the science output as well. And so maybe it's just that they're actually producing a lot of papers, and so the results may be skewed that way? Or is there a deeper thing going on?
Yeah, look, I think definitely China is producing a lot of output. There's no doubt about that. I think it's surpassed the USA maybe a year or two ago. And so I think that's definitely part of it, just a lot of output. But I suppose we are, nonetheless concerned that, we would have screened a lot of papers from the US, and yet the rates of incorrect papers in the US is much, much lower than China. And it is also, this unusual sort of concentration of papers from hospitals. I've thought a lot about this because prior to my current job, I worked in a hospital for over 20 years. So I certainly know that, hospitals can carry out basic or preclinical research, but in a general sense, most hospitals focus upon research that's relevant to their patients. That's what they value. So seeing a lot of preclinical papers from hospitals with errors is a bit difficult to understand. Yeah. And
is that not potentially quite dangerous? Because a lot of research, ultimately, if there's errors in it, it only really affects and annoys us because it bothers us and not doing our work, but it doesn't necessarily impact the public. Whereas preclinical work and certainly stuff coming out of hospitals often is used more by people who are maybe suffering from a disease that paper's talking about, or they are more likely to then go on to have clinical relevance. So is that not that's potentially quite concerning then.
Yeah, definitely. I mean, a lot of these papers are cancer research papers, so they are studying gene function in cancer. Some of them go a step further and study gene function in cancer in combination with a chemotherapy drug. So one of our groups of papers actually was looking at 2 chemotherapy drugs, which are very widely used in cancer medicine, cisplatin and gemcitabine. But then the screening work also identified some of these other, in one of the journals in particular, where, papers looked at genes in combination with cancer and chemotherapy drugs. So some of those papers, I think, start to step closer towards the clinic, saying that, well, in this cancer type, really the issue is that you need to combine these 2 genes with this drug, and then things are going to work better. And as someone who's worked in cancer for a long time, I doubt that things are that simple. Some cancers that are studied by these papers are cancers that have had virtually no improvement in clinical outcomes in 20, 30 years. They're clearly formidable challenges. They can't be solved by simple approaches. But I worry that the message of these papers is just that, that it's kind of like, mix these 2 things together and we're going to have better outcomes for patients. I'd love to think that's true. I just don't think that that is the case.
Yeah. And did you notice any kind of correlation between the journal and the number of mistakes? So, for example, were those higher impact journals having fewer mistakes?
Ooh, well, not really. Yeah, I think we haven't looked at it in a systematic way. But the 2 journals that we studied were Gene and Oncology Reports. And I think, Nori, their impact factors are not very different.
No, they're quite similar. Can't remember the exact number, but it was within like 0.5 maybe.
Yeah, that's it. Yeah, they're both quite similar, and I think they're quite different journals, very different journals. So Gene is a much broader journal and publishes a lot of research that's non-human. And of course, we didn't screen those papers. So certainly the error rates amongst the human research the overall error rate in Gene was lower than Oncology Reports. But Oncology Reports is a journal that primarily publishes human cancer research. So, we would have screened more papers in that journal. But yeah, there was a fair difference. But impact factor, it's hard to say. We're doing some research now where we're starting to look at higher impact factor journals to see whether papers with errors are also found in higher impact factor journals.
I can tell you they are. Don't know how many, but they are.
Yeah, I know. It's true. Yep. It's a bit, to be honest, it's a bit of a shock. Yeah.
And I mean, so when you're blasting a gene, you can sometimes have your on target, but then you can also have other targets that, depending on the application, could actually be quite problematic. How did you handle those situations?
I think, Jenny, you might be happy to just step in here, but I think for me personally, I was quite lenient. Obviously, off-target effects aren't really ideal, especially if you're talking about RNAis where you want to specifically target just one gene. But I think the approach we had was that we were kind of looking for mostly sequences that were just blatantly wrong. So there weren't really that many instances actually, but if there were cases of a sequence kind of targeting one gene and then happened to also actually target another gene quite well, we decided to just still call it as it's okay. At the end of the day, we were just kind of concerned with whether or not it targets the right gene or not. And it does. I mean, it also had targets another gene, but it still targets the gene that we're interested in. So we decided to just call it okay.
Yeah, no, that's right. Yeah, we felt that we were more assessing the claims in the paper in terms of, could this sequence target this gene? And if it could, yeah, okay, good. It could have targeted another gene? Well, maybe, but, still the claim is correct. So we didn't try to do things like really, like, for example, map PCR primers on the genome and work out that they could have conceivably produced a 436 base pair product. Right? No, we didn't go that far. It was more, is this a primer for this gene? Yes or no?
Yeah, no, it's just, again, something I've anecdotally kind of come across is there's a lot of bad primers out there where, I mean, sometimes it is just really difficult to design a good primer, but there's a few I've taken where, to be honest, you wouldn't have a clue what gene you're actually amplifying in a qPCR reaction, because there's a lot of products that are the same size or close enough that you're amplifying those two. And then when I've if this is something I've had to use and I've had to design primers subsequently for, I found that in some cases I have actually been able to design a decent primer. So I wonder, I mean, some of that, there's definitely a lot of that out there as well, I suspect.
Yeah. And I think that in a way is something that concerns us about these primers, because we know that, like, you take primers, it's not like it's not like you take primers, put them into a PCR reaction, and 3 hours later you got a result. It's not that simple. It takes time and effort to often get reagents to work. So sometimes people will take these reagents, they don't work, and they'll go, oh, well, that happens. Let's keep trying, But with some of these reagents, you can try until the end of the earth, and they're not going to do what you want them to do. So I worry about the potential for just wasting a lot of time.
Yeah. And was there any individual gene or group of genes that had more mistakes than any other? I mean, housekeeping genes, I imagine, come up, the same kind of housekeeping genes probably come up quite a lot, so there's a greater chance they might have errors in them, I guess.
Yeah, no, definitely right there. I wish I could point out one specific gene and say this one's a nasty one, but that might be a bit rude to say. But GAPDH and actin beta came up a lot. I think they were two of our most common off targets, actually. So when I'm being off target, just like they were wrong most of the time. That's not too surprising to me, given that you expect to find them in almost every single reaction, just as a control. But other than those, I don't think there was anything too common there. Yeah, it was all actually surprisingly spread out, which I don't know if that's a good thing or bad thing, to be honest.
Yeah, I was surprised by that. I think we expected from our very early results, we did see particular kinds of non-targeting reagents that target specific genes, and we saw those repeated over and over. But we kind of expected that we would find that. And we also expected to be able to derive just a nice little table of, here are the sort of top 10 incorrect sequences that just happen all the time, and we could screen for them. And sadly, that is not what we found at all. We found a lot of reagents that only occurred once. That's not surprising. The genome's 3 billion base pairs long, but it makes the job of finding these things so much harder. It's not a case of people just using the same thing over and over, and that's, tough.
A little bit off topic, but one of the steps we use in screening the sequences was just searching it in Google Scholar, and occasionally what I'd find by the time I got to that step where I'm going, I don't know what the sequence is, was every now and then I'd find the sequence published in another paper, but for a completely different target. So it's a bit interesting there where you kind of see, okay, well, chances are they might have gotten it from that paper. I'm just not sure what happened in between for them kind of deciding to change the target.
Yeah, that is interesting.
Yeah, weird.
I mean, a lot of people do that, right? They do just go to the literature, take a sequence and go, yeah, that'll do. We'll use that. How the name changes is
yes.
Yeah.
But yeah, Google Scholar, it's a useful tool to just we do scan Google Scholar, just see, has anyone else ever used this, And a lot of the time you'll put things into Google Scholar and Google Scholar's never seen it either or can't find it. But yeah, quite a lot. We do sort of get clues about its past use. Doesn't really tell you what it is, but it tells you how it's been described. Maybe that's kind of, Nori's forensic approach too. It's just another piece of the puzzle, I think.
Where do I find out about the different bioarchive licenses? This CC, BY, CDXY nonsense is driving me nuts.
ASAP Bio have a resource for that.
Ugh, that's your answer for everything.
That's because they have everything you need to know about preprints.
Sure, they probably have the basics, like info on the preprint servers, but what else is there?
There's so much more. Looking to post a preprint but not sure what different journal policies are? They have a collection to help you out with that. There are meetings around preprints and associated services. If you want to know how preprint adoption has changed over time, there's even a page on that.
And COVID?
They have a big section on preprints and the pandemic, plus some really cool infographics for communicating preprints.
And university policies? Surely they don't have that.
They collect uni policies where possible.
Okay, they do sound pretty impressive, but is it not a bit of an echo chamber?
It can be, but ASAP Bio also engage with people who don't love preprints and have concerns. So we had an excellent discussion on this very topic a couple of months ago.
Oh, is there anything ASAP Bio don't do?
Honestly, no, they're so nice over there. They were so quick to jump in and support this show. It's your one-stop shop for info on preprints and open science initiatives, so head over to asapbio.org to learn more and subscribe to their newsletter for the latest in preprint news. If you want a deeper dive into the world of preprints, then look out for the next recruitment of ASAP Bio fellows.
So one of the things we like to do here is to talk a little bit more about sort of your experience with preprints, why you preprint, that kind of stuff. Because we're big fans of preprints here. And one of the reasons we're doing this podcast is to try and sort of, discuss really cool science with really cool people, which is the best bit. But then we also try and get a little bit about why people should be preprinting out as well, so that we can justify being funded. So why did you decide to put this out as a preprint?
Well, I guess that was probably my decision as well. But Nori and I published a paper together earlier this year where I was thinking about doing a preprint. And I can only really say that I just chickened out. I just kind of went, I don't know, I've never done this before, I'm not going to do it. But then with this one, I really thought, no, like we've been working on it for so long, it's so much work, and it's just important that it's out there. So I was really, really committed to preprinting this paper. And look, it's been a great experience. It was fantastic. I'm a convert. I'll definitely do it again.
Yeah, that's what most people say when they do it. What benefits have you noticed from preprinting?
Just think getting it out so much more quickly. One of the challenges with this kind of research is it's kind of between different fields. So we wrote this paper very much for a genetics audience and a genetics journal, a biomedical journal, but previously we've published in more meta-research journals, which is great, but sometimes you're preaching to the converted. We want the people that are actually going to use this research to see it. And so, that process can just take a long time. You can go to journals and they can say, oh no, or the other tricky thing with this preprint is that, the reality is that some genetics journals that we may want to submit to have probably published these kinds of papers. They may not be too thrilled about our paper appearing in their journal. So that's tricky. And so really, but at the end of the day, that stuff's not very important. The important stuff is have it in the public domain so that people can see it and people can start learning and start thinking about how they approach the literature.
Everybody should be blasting your own primers.
My
please.
Goodness. Oh, yes. Oh, yes. That really, I just can't emphasize that enough. It terrifies me that people might be basing a PhD project or something on some of these papers. It doesn't bear thinking about, really.
Yeah.
Oh, sorry, I was just asking, is there a particular downside to preprinting? It's not really a concept I've actually heard of before Jenny brought it up.
Yeah, so there are a lot of people who don't like preprints and have a lot of arguments against preprints, but ultimately there aren't really any true downsides. The biggest downside I would say is that some journals won't allow you to submit if you post a preprint, but that number of those journals are decreasing like every day. The other downside, and this is another question I want to bring up actually, because this has been very big on Twitter for the past sort of week or two, and that is some grant agencies don't like preprints.
Yes.
Now, in the UK, all of our funding bodies now require you to make your work open access. The easiest way of doing that is to just post a preprint, because then it is open access, even if you then put it behind a paywall later on. And the other thing a lot of the funding bodies here in the UK do is that I think they all allow you to put preprints as evidence of outputs. So this is particularly good for early career researchers who, I've known people who've worked in labs for 3 or 4 or 5 years, and they've come to apply for their fellowship to start their own lab, but they haven't had a chance to publish a paper in that time, because what they're doing is aimed really high impact journals, and it takes a year or more to get the paper published. And this is their last chance to apply for these fellowships. Without a preprint, they wouldn't have got it, because it would look like they've actually done no work, which is not true. So there are some issues, but the issues, to be honest, are not with the preprint, they're not with putting it out there, it's just with people who are, I think, stuck in a very old-fashioned way of thinking, which is what I've told them myself, so there's nothing new there for that. But yeah, the big thing on Twitter at the moment has been the ARC funding in Australia, and that if anyone's not familiar with this, there was a recent grant funding round, and in the instructions to authors, there was a small bit saying you're not allowed to cite preprints anywhere at all in your application. People did, because it's not a very big thing, and that was in the clear instruction. And a lot of grants have been just outright rejected on the face of using preprints. And this has caused, in my circles, we're all very pro preprints, so it's caused a whole uproar in my circles. But I think generally it has within the community. Jennifer, you're probably the best person to speak about that, but how has that been across?
Yeah,
across research?
I'm actually really glad that I'm glad that you'd seen that, because I was going to mention that. It's a huge issue here in Australia. I think the rule about not citing preprints was clearly something that was not clear to applicants. Yeah. And also to university research officers whose job it is to go through these applications with a fine-tooth comb and remove any potential causes of ineligibility in these applications. So the fact that, quite a lot of these applications ended up in this situation indicates that clearly the applicants didn't know and the research officers didn't know, so the universities didn't know. So that it clearly wasn't clearly communicated. And people are outraged because they feel that, at times you have to cite a preprint. That's what's there. It's not so much, even in your research proposal, you can't refer to preprints. And people were saying, well, that's a matter of research integrity because you're not actually citing the literature that exists. You're not presenting the evidence that existed when you wrote your application. So there's a lot of people very unhappy. There's a petition that's going around, which I've circulated on Twitter as well. And I think the NHMRC, which is the organisation that's funding Nori and myself, they have very recently come out and said that they accept preprints, which is great. So it'll be interesting to see whether the ARC, what happens there, because it's heartbreaking for people to miss out on such a minor technicality. I mean, really, goodness.
I mean, I suspect it's been done as a way of weeding down the numbers easily, and it's a very lazy approach. So ASAP Bio, who fund us, I work with Jessica a lot. They've also done a letter out as well, an open letter for the research community to sign. That's great. Which Emma is now going to have to go and find and link in the show notes. It'll be easy to find. But yeah, it's just I really struggle to understand. I quite often get into small arguments on Twitter with people who review grants and things. There was one recently where the guy just outright refused to look at a preprint if it was in a grant application, but would happily count abstracts, which are useless really, but will not read a preprint because he doesn't like preprints. And this is one the downside to preprints is just people's mentality, to be honest. That's the biggest issue.
But the thing about preprints, it's not like they're hidden. It's clear. This is a preprint. Like everyone knows that.
Yeah, as you say, it gets to the essentially misconduct if you're not citing the literature just because you don't like it. Now I can understand if you can't read a paper, then I fully support not citing it because you can't validate the results. Ultimately, which is ultimately what we should be doing when we read papers. But with a preprint, you've got no excuse. You can always read it. It's always free. You can read it. So why would you not cite a preprint? I don't understand why people make these kind of decisions.
Yeah, hopefully it's, hopefully it will be the last time,
Hopefully, hopefully they go back and think about changing some of those early rulings out as well, because it's just not.
Yes, no, it's terrible. I mean, people are stressed enough with COVID and lockdowns and restrictions on research, and really this kind of thing just shouldn't be happening.
Yeah. No, absolutely not. So in happier news, though, you're a very collaborative lab. So, how do you find that? Because I always think recently I've started to do sort of my own collaborations for the past year, and that has probably been the most fun I've had doing science. So how do you find it?
I think, the collaboration is great. And in this kind of field, Nora and I know about sequences, but I don't know anything about programming or, I certainly didn't know anything about text mining before I started this kind of work. So, it's really exciting to work with people that have such different backgrounds, such different expertise. That's a lot of fun.
And it's a pretty international collaboration too. So how do you manage those kind of collaborations with everyone on different time zones? I find I have a lot of meetings in the late evenings.
Yeah, it is a bit tricky. We do have some meetings where we can usually find a time like early in the morning, late at night. I did my postdoc in France, so I suppose I've got a bit of a affiliation for France, and I've worked with other sort of French colleagues in particular, so that's always been really nice. But I guess for Nori, this is kind of like a new experience, isn't it? You wouldn't.
It is.
I think in your previous roles, did you have a lot of?
No, I was all on my own. I was not too. I guess, I don't know, my previous job, I was mostly on the night shift. So the idea of, maybe having to stay back a bit just to chat with someone isn't too bad. Luckily that hasn't happened yet. But it's not that tricky. Or maybe it is, but it's not as tricky as I thought it would be. Yeah, everyone kind of seems to be on board on the same page. If there is someone off page, it's usually quite easy to just go like, this is what I meant.
Yeah, I think we can. I think probably COVID's helped in that sort of thing. A lot of improved, very, very rapid improvements to sort of video conferencing and things like that. Yeah, but no, it's good.
Yeah, I think COVID has opened up people's thinking a little bit, because I used to hate doing like Zoom calls and stuff, but COVID normalised it, and now perfectly happy to do them.
I think probably in Australia we're more used to that sort of thing. Like we know that we're a small country at the end of the earth, so and that's the reality. So we often end up doing things at odd times, so that also isn't too unusual. Yeah. Although sometimes it's been a bit of a stretch this year where conferences, I think, go from midnight to 8 o'clock in the morning and stuff like that. But anyway, you survive.
Yeah, no, I've missed quite a few in the US because of weird times. I'm not committed. I'm not committed enough to stay up all night for a conference. I'm not there in person.
That's understandable.
Yeah.
My own cooking skills it's not worth it. If there's free food at a conference, I'll take that.
Right. Yeah. Look, in Australia, you can't say that. It's always going to be at some terrible time. You just got to get in and do it, I think.
And Nori, how was transitioning from a sort of COVID lab to an academic lab?
Oh, it's so much nicer. I don't know if you've had the chance to talk to anyone working in a COVID lab. If I can speak for Australia, where I imagine right now they are not having a great time. Especially with pathology, one of the things that's demanded is kind of a turnaround time, getting the results out as soon as possible. And unfortunately, if you have a lot of samples, that means you're running a 24/7 lab, and it just means you're going to be, even if you're not at work, you're going to be on call, and good luck trying to get 8 hours of sleep because someone's probably going to call you. So kind of just coming from that to a role where Jenny's really supportive, where it kind of is, sometimes you work more than you expect to, but once that's it, then that's it. And being in a role as well where you can actually kind of use your brain, whereas with COVID, a lot of it's quite autonomous and standard. The only time you're really thinking is when things go wrong. It's like, oh, how do I explain this? I'm loving it. Yeah, perhaps the only downside might be it's not the most stable role, I imagine. But with all the other pros, I'll take that over a COVID lab any day, to be honest.
Yeah, no, we've got a couple of friends who worked in different COVID labs, and
okay.
One of them's now back in academia. The other one isn't going to be coming back to academia. But they've said similar stuff really to what you said. Actually, it's been I think they found it, like you said, very autonomous, and it is a lot of just kind of ticking over, doing the same thing a lot. But it's good that you're enjoying academia. We often have conversations with people who are not enjoying academia.
Might be because I haven't done my PhD yet.
That'll be it. You're still youthful and hopeful and not broken by the system yet.
Not yet.
It's great. There's a lot of great things about academia. We're actually doing quite a big another international project at the moment, reviewing all the literature on sort of the research and academic culture and working environment and stuff. And it turns out when you sit and look at all this, it's incredibly depressing. But we still love academia. It's still great. I still want to stay in it. So
how far back is that going?
So we're kind of at the moment we're still just kind of getting started up. But we'll be looking at mental health issues. We'll be looking at the sort of contract length, pay related to other sectors. We are massively underpaid. Working hours, all that kind of stuff. And then also the other side, which is what I do more often, which is the publishing aspect and the problems with peer review, the gatekeeping in publishers that publishers do and editors do, grant funding issues, which is good for me that the ARC issues came up because then I've got something to talk about. Unfortunate for everyone who actually applied for it. But it's all those kinds of stuff. We're just trying to collate it all into one place because there's a surprising amount of research on research. It's just not in one place. And I think a lot of scientists don't even necessarily realize there's so much research on how we do research.
Yes, that's right.
Which I guess is the other lesson we should be telling everyone, to really think about how you do your job and how you approach research, because that is something I think certainly as you go further through, you kind of just fall into doing the same things over and over. And I think it can be really helpful to step back and think about the process that you're actually doing, and are you doing your science the best way you can? Are you communicating your science the best way you can? And preprints, I think, are a really good example where somebody could have never been doing them for a long time, then they do them. And as you said, generally, people have an amazing experience when they do them.
Actually, that makes me think of another, I think, an advantage of a preprint. I think sometimes when people submit a manuscript for peer review and it's going behind closed doors, they'll kind of go, this is good enough. But Nora and I just, we nearly killed ourselves over this thing because we knew that it's going to be live, And so, we worked really hard. And I do think it's possible that that does improve the quality of the manuscript. If you know it's live, everyone's going to read this. You can't sort of count on it just being hidden behind a journal, and I think some people deliberately send manuscripts into journals and kind of go, well, help us with this, fix it up a little bit. Yeah, with a preprint, all that's out in the open.
there's so much anecdotal evidence again of people who hold data back. They've got the data, but they don't put it in the paper because they want the reviewers to ask for it, and it's an easy give to the reviewers. I mean, I've been in labs where we've done that before. Whereas if you put a preprint out, if you view that as the epitome of what you've done, then it's all going to be in there, and you're going to have a much stronger paper to begin with.
Yes.
But that does come back to how we do peer review and how that needs to change. But yeah, no, it is. It's something a few people have said to me when they've preprinted for the first time, is that actually, because it is out there and it's public, they put a lot more effort in than they necessarily do when they submit a paper, because they know the paper's going to change and people aren't going to read it until it's changed. So there you go. That is a really good benefit actually of preprints, and that's probably why when we did our work, we found that generally the quality was really high.
Okay, interesting.
Although we don't know about the preprints that I never published. We haven't done that yet. It's follow-up work. Okay. I think that is the end of my questioning. Emma, have I missed anything? I don't think I have. Well, thank you so much. I've really enjoyed this conversation.
Thank you for having me.
Yeah, thank you.
It's been really lovely talking to you both and getting to know you, and good luck with whatever you're doing in the future. If it's a PhD, Nori, good luck with that.
Yeah, thank you. We'll see.
Don't let us all put you off.
It is fun. It is worth it.
I would always, like, if I went back now, I would still do my PhD easy choice. Would never not do it.
Oh, that's really good.
Yeah, that's how I like to think of it. I wouldn't go back and go, I will never do this. I never want to go through that again. I would still choose to do a PhD. So I think that's
and it's just an amazing life experience.
Yes.
I think so. Yeah. No, it's something that I think you always look back on. You remember it. It's a great intellectual opportunity,
Definitely.
I think. That's what I really
And it's your
enjoyed,
last chance of actual freedom before you have to do a real job and be an adult.
Yeah.
And being an adult's not fun, so if I could do another PhD, I probably would.
I wouldn't go that far.
I'm glad to hear it's not all doom and gloom.
No, it's not.
But thank you for having us on the show. It was lovely.
Yeah, thanks so much.
Thank you so much. Okay, and that is the show. If you enjoy listening, then hit that subscribe button for more and leave us a review on whatever platform it is you're listening on. You can reach out to us on Twitter at MotionPod or online at preprintsandmotion.com. Didn't enjoy that? Well, we're all scientists here, so send us your review and let us know what works or what you'd like to hear more of, or less of. But until next time, have a good week.